Proportionality. Let's go. The distance needed to stop a car D varies directly as the square of the speed S at which it is traveling. So in the first sentence, they are giving us two quantities. They're giving us distance, and they're saying that is directly proportional to the square of speed, which means S squared. So from that, I could form a relation. So D is proportional to S squared. This symbol means directly proportional. So D is directly proportional to S squared. Then I could form my equation. So it's going to be equal to Ks squared. Now, K is the constant of proportionality, and it tells us how D and S squared are linked together. So you're probably saying, wait, sir, nah, I cooked. That's real unknowns. So here what? We're going to actually use the next sentence to find for K. A car traveling at a speed of 70 kilometers per hour requires a distance of 40 meters to make a stop. So in the second sentence, they're giving us a given set of information. So they're telling us when the speed is 70 kilometers per hour, it's going to take 40 meters for it to stop. Now, some of you might be like, sir, don't we have to convert meters to kilometers? And the answer is no. If you do, however, do that, the final answer you'll have to convert back to meters. But let's continue. So over here we have speed and we have distance. If I were to plug that into this equation, I'd be able to find for K, because K will be the only unknown now. So D is 40 meters. I don't know what K is, and I know that S is 70. So what is 70 squared? 70 squared means 70 by 70, so that's going to be 4,900. So K is being multiplied by 4,900. So to find for 1K, I would need to divide both sides by 4,900 such that they would cancel off. So the 4,900 cancels off with this, and that leaves us with just K. So K now is going to be equal to 40 over 4,900. Now, if you plug this into your calculator and it cannot simplify, leave your answer as a fraction. But this could be simplified though. So the zeros would cancel off, and 2 could go into 4 2 times, and 2 could go into 490 245 times. So K could be simplified 2 over 245. Now again, since we kept the distance in meters, it means that once you plug in S in kilometers per hour, you're going to get distance in meters. So I know what K is, so now I could write my full equation. So D is going to be equal to 2 all over 245 multiplied by S squared. Awesome. So now we have a complete relation linking D to S squared. So now we can answer the last question. What distance is required to stop a car traveling at 80 kilometers per hour? So in this question, they are giving us S, which is the speed. So we have speed, and we want to figure out for the stopping distance. And wow, look at this. This equation is the perfect thing to solve for that. So we know what S is, so I could substitute that, and as you can see, that would leave me with D being the only unknown, so I could solve for D. So I am going to now plug S as 80 into that. So it's going to be 2 over 245 multiplied by 80 squared. And when you plug this into your calculator, let's see what you should get. So 2 over 245 multiplied by 80 squared. When you plug it in, you should get to the nearest meter. You should get 52 meters. And probably saying, well, sir, nah, real confused. Remember, we did not convert the distance to kilometers. So that means when you solve the equation, your distance is automatically going to be in meters as well. So this is my final answer. Now, if you had converted the distance to kilometers, you would have had to divide it by 1,000, and you would have got 0.04 kilometers. So what this would have meant is that when you solve your equation, you're going to get a final answer to be in terms of kilometers. So as you can see, we would have done the long working over here, and our final answer would have been 0.052 kilometers. But if you want to write your answer as meters, you then have to multiply it by 1,000 to convert it to meters, and you will get the same 52 meters. So my advice is, do not convert the meters to kilometers. Leave it as is, because the constant of proportionality is going to absorb the units. And so once you keep everything consistent and you use speed as kilometers per hour, you will get your final answer for distance in meters. So I hope you learned something new, and until then, see you guys in the next video. Oh, I forgot to mention, with all of these questions, there's a very similar procedure. So the number one thing you're going to do, you're going to make an equation. Look at the relationship and make an equation. So I would say D is proportional to S squared, and then I would say D is equal to KS squared. I would substitute a given set of information, and I would solve for K, and I would then plug that into the equation to complete it. So make the equation, solve for K. So we solve for K, and then we're going to use this to answer our question. So as you can see, I came up with my equation, I solved for K, I plugged it in, so now I have my complete equation, And I now use this to figure out distance required to stop the car traveling at 80 kilometers per hour. So this is the general procedure. You're going to make an equation, you're going to solve for k, write a complete equation, and then use that to answer the final question. So good luck in your exam, guys.